Ever get that feeling? Like computers just don't quite get how we talk.
Yeah, I know what you mean.
Type in a search and it's like, did we even speak the same language?
Totally. It's like that disconnect. Human intuition versus how machines process things. That's been a huge roadblock for NLU, natural language understanding.
Exactly. But that's what's so cool about this research we're diving into. Improving language understanding by generative pre-training. Bit of a mouthful, but it's making serious progress on that front.
Big time. Game changer, really. This research, it's like the foundation for all those crazy good language models popping up now.
No kidding. All right, so we're going straight to the source. Excerpts from the actual research paper. It's dense stuff, but that's why we're here.
Absolutely. We'll break it down, make it a bit digestible.
All right. Perfect. So first up, pre-training. Imagine like teaching a kid about the world before school, right? Reading to them, talking, just exposing them to stuff.
It's like that, but with a computer model instead of a kid. And mountains of text instead of, well, bedtime stories.
So like a digital bookworm devouring a whole library.
Exactly. And by taking in all that data, books, articles, everything, the model starts to get how language works. Not just memorizing words, but like the actual grammar, the relationships between words. Even absorbing knowledge and how to reason just from reading.
Wow. And how does that translate to like actual results?
Okay, so get this. On some tasks, we're talking accuracy jumps of almost 9%, 8.9% to be exact. Which, in the AI world,
That's huge, right?
massive. Previous improvements were usually tiny fractions of a percent. This is a total game changer. Everyone was suddenly hyper-focused on pre-training.
Makes sense. Okay, so we've got our pre-trained model, a digital Einstein with a head full of info. But how do we actually use that knowledge to make it understand language like we do?
That's where the transformers come in.
Wait, like Optimus Prime?
Haha, not quite. Although the name's a funny coincidence. Transformers are a type of neural network built specifically for handling language.
So like the key that unlocks everything.
Exactly. You see, older models, they struggled to remember information from earlier parts of a text. Imagine trying to follow a conversation, but you keep forgetting what was said, like 2 sentences ago.
Ouch. Yeah, not good.
And not good for AI either. But transformers, they've got this incredible ability to hold on to information and connect it, even across long, complex sentences.
No more digital amnesia, huh?
Exactly. It's called long-range dependency, and it's a game changer. It's what lets transformers understand things like pronouns, references, the whole flow of an argument. Things other models just couldn't quite grasp.
Amazing.
Huh?
Okay, so we've got our prodigy prepped. They've got their transformer superpowers. Time to put them to the test, right?
Time for the test. And this is where it gets really interesting. They really put it through the ringer. Answering tough questions, figuring out if 2 sentences meant the same thing, even predicting the next word in a sentence.
Like a linguistic Olympics for AI.
Exactly. And remember, those 8.9% accuracy jumps, well, those were on tasks like the RACE data set.
Race E. Remind me.
Right, so RACE stands for Reading Comprehension from Examinations. Basically, passages and questions pulled straight from real middle and high school exams.
Whoa, so we're not talking about like simple vocab here. These are questions that really make you think, understand the context and everything.
Exactly, and this pre-trained transformer model, it aced those tests. It proved it could handle some seriously high-level comprehension.
That's incredible, but it gets even wilder, right? This research also got into zero-shot learning.
Now, this is where it gets really mind-blowing. Zero-shot learning, in this case, means the model figured out how to do new language tasks without being trained for them specifically.
Hold on, how is that even possible? It's like showing someone a cookbook for the first time and they whip up a gourmet meal.
Right. It's amazing. It's because during that pre-training, the model developed this deep understanding of language itself, so it could transfer that knowledge to totally new situations, figure things out on the fly.
So it's not just memorization, it's learning how to learn.
You got it. And that's what has researchers so excited, this ability to learn and adapt. It hints that these models are developing something like a fundamental grasp of language, not just the surface level thing.
So back to our kid analogy, it's like they've gone from listening to us read to picking up a brand new book and understanding it all on their own.
And not just understanding, but maybe even making connections to other books, critiquing the writing, even starting to write their own stories.
Now that is an exciting thought. But before we get ahead of ourselves, let's ground this a bit. What were some of the other big takeaways from this research?
Well, one thing that stood out was the importance of data quality for pre-training. We talked about that massive data set of books and articles.
Yeah, a whole buffet of knowledge.
So, turns out, Feeding the model longer, more complex texts, like those in books, led to much better performance than shorter stuff, like tweets or social media posts.
So it's like they say, you are what you eat. Even for supercomputers, a diet of Tolstoy beats a Twitter feed full of memes.
Precisely. It shows how crucial that high-quality data is for shaping these models. And speaking of data, another interesting finding was the comparison between the Transformer model and those older LSTM models, long short-term memory.
LSTM versus Transformer, huh? Close match.
Not really. LSTMs, they're good, but they consistently lag behind the Transformer, especially with those long-range dependencies, the connections within the text. Transformers were the clear winner.
So Transformers are not just a fad, they're a real turning point in how we approach language and AI.
Absolutely. And this research, it was like a catalyst, paving the way for all these amazing models we have now. ChatGPT, Bard, the list goes on.
Wow. So not just a step forward, but like a launch pad for a whole new era of NLU.
Exactly. And honestly, we're just getting started. What's possible with this technology? It's really incredible.
This is seriously cool stuff, but let's bring it back down to earth for a sec.
Yeah, good idea.
Hmm?
Always smart to ground ourselves after, AI space travel.
Exactly. So we've covered the what and the how of this research, but the big question is, why should anyone care? What's the real world impact here, besides like slightly less frustrating chatbots?
Right. That's the question, isn't it? And honestly, it's not just about making what we have a bit better. This is about a fundamental shift, like how we even interact with computers and, in a way, with the world itself.
Okay, now you've got me hooked. Paint me a picture here. What does a world transformed by this level of language understanding even look like?
Okay, so imagine, like, education, but truly personalized. Every student having an AI tutor that gets their learning style, answers their questions instantly, adapts to their needs.
No more one-size-fits-all classrooms.
Gone. That's huge, especially for students who don't thrive in that traditional setting.
Makes sense.
And it goes beyond education.
Yeah.
Healthcare, huge potential. We've already got AI looking at medical data, but imagine doctors actually talking to these systems. Like real conversations, complex questions, getting deep insights to diagnose things earlier, make treatment plans better.
Wow. So it's like a whole team of specialists, but digital, working right alongside human doctors.
Exactly. And honestly, we're just scratching the surface. AI legal assistance, marketing that truly understands what people want. The possibilities are kind of mind-blowing.
It's almost a lot to take in. Like, we're at the edge of something really big here.
It's an exciting time, that's for sure. But it's not just about the tech, it's how we use it,
Yeah.
right? We got to talk about this stuff, the good and the bad that come with such powerful tools.
For sure. Great power, great responsibility, and all that.
Exactly. As we unlock the secrets of language, we got to make sure we're building a future where humans and machines work together, each playing to their strengths, creating a world that's both high-tech and deeply human.
Couldn't have said it better myself. Well, folks, looks like we've reached the end of our deep dive for today. But before we go, one last thing to think about. We've been talking about computers learning from text, right? But what if we took it further? What if instead of just reading, these models could learn through talking, like actual back and forth with humans?
Now, that is a fascinating thought, and I have a feeling that's going to drive the next wave of breakthroughs in AI.
I'd bet on it. So until next time, keep those brains buzzing, and remember, when it comes to the future of language understanding, the conversation is just getting started.